So last time, we reviewed how to solve right triangles like you would have in your geometry course. We noted that the techniques we used in the right triangle situation could not be used in any triangle situation. We introduced two new tools that we can use in any context, the law of sines and law of cosines. We observed that depending on the given information, we noted which of the two we'd want to use, law of sines or law of cosines. We saw that with the law of sines, we'd use that in the angle, side, angle, angle, side, and side, angle situation. For law of cosines, we would use that in the side, angle, side, and the side situation. We went on to talk about the SSA situation where there's a little bit of complications involved. That basically there were three cases that you can run into, and the one that we have to be super careful about is the case where the angle that's given is acute and the side opposite that given angle is shorter than the other given side, because in that case 0, 1, or 2 triangles can occur. And we talked about how to tell that situation apart. We said that you can do the longer side times sine of the given angle, divide by the shorter side, and look at the result of that number. If that number was bigger than 1, you get no triangles. If it was equal to 1, you get exactly 1 triangle. And if it was smaller than 1, we get 2 triangles. And that's kind of where we left off last time. Today, we're going to start with some examples of some of these other situations we haven't talked about yet. So last time we did one, I think it was an angle, side, angle situation. We're going to come here and do a couple more examples to finish up today. So let's say that we have a triangle here with an angle of 56. Angle P equals 56, side P equals 16, and side Q equals 17. When I said 17, I really meant 19. So I'm going to go ahead and draw and label a triangle here. So obviously one vertex should be P. Since I have a side Q, another vertex should be Q. And what do you think I'm going to name the third corner? R for all my pirates out there, because, well, the alphabet. We'll label our side lengths using the same naming convention that we had talked about, where we're going to name the side opposite the angle as the lowercase version. So here's my picture. What situation are we in here? I got two sides and angles. This side angle or side angle side? This is side angle. So I know in this case we're going to be using the law of sines. But before we do side angle, there's some things we have to check because weird stuff can happen in this situation. The first thing we need to do is we need to look at that given angle and decide whether that's acute, right, or obtuse. In this case it is acute. Okay? Since it's acute, we need to then compare the size of the side opposite that given angle with the other given side. So in this case, is that side opposite the given angle bigger, equal, or smaller than the other given side? Smaller, right? P is less than Q. So this is, in fact, the 0, 1, or 2 triangle situation. Uh-oh. We saw to analyze this situation, we take the longer side, multiply it by sine of the given angle, and then divide it by the shorter side. So let's go ahead and type this into our calculator. What do I have to remember when I start typing stuff into my calculator? Got to check the mode. The mode in this case should be degrees. How do I know it's a degree mode problem? Because the angles are given in degrees. Yeah, it's that simple. Again, we've mentioned this a couple of times, but it doesn't hurt to keep mentioning it because what is this? We're reviewing. So I got 0.984. I'm going to compare that number to 1. Since that number is smaller than 1, it tells me we're in the two triangles situation. Does everybody feel okay with the steps I kind of used to analyze that? Okay. As a teacher, one of the most common mistakes see students make on these kinds of problems has to do with organization and like information management. Since we have two triangles and we have two sets of information, we need to be really careful that we're using the right information in the right context. So the first thing I'm going to do is I'm going to set up a space to record my answers for each of these two triangles. Now, the information for angle P, side P, and side Q, that's the same in both triangles. What's going to be different is the values for angles Q, angle R, and side R. To differentiate those, I'm going to put a subscript of 1 and a subscript of 2, depending on whether we're working with the angle Q in triangle 1 or triangle 2. Similarly with the angle R and the side R's. Everybody cool with the way I've named my variables and such? And I like to go and make a little list, so I've organized them really well. The next thing I'm going to do for organization is I'm going to make a space where I do the work for things involving triangle 1 and another place for things involving triangle 2, so that I don't mix up my calculations for the two situations. So I just kind of divide and work for one triangle into one column and the other triangle into another column, just for me to keep things straight. Now typically here what I like to do is I like to do everything for triangle 1 first and then do everything for triangle 2 second. It wouldn't be wrong to hop back and forth from triangle 1 and triangle 2 and do each thing as you go, but to me that just seems like more opportunity for me to like use the wrong number in the wrong spot. So I like to go straight down through triangle 1, finish that up, and then go straight down through triangle 2 and finish that. That's what I'm going to do here. I'd encourage you to do the same, but it's not wrong if you wanted to do something different. So far, so good? Okay. So starting triangle 1 is going to be like any other law of sines problem. So I'm going to look for a situation where I know both the angle and at the opposite side. That's P. I know angle P and side P. And then a situation where I know one of either the side or the opposite angle, or the angle or the opposite side. That would be Q. Everybody agree? So we'll start by just saying sine P over P equals sine Q1 over Q. So I will cross multiply. So 16 times sine Q1 equals 19 times sine 56. We'll divide both sides by 16. And then how do I get rid of the sine in front of that Q1? Sine inverse. So Q1 is going to equal sine inverse 19 sine 56 over 16. And then it's calculator time, right? Notice on these problems, I'm trying to do a good job of making sure I put the degree signs on my angles. It's very easy to get confused at points and about whether something's a side length or an angle measure. So I would encourage you to make sure you're putting your degree symbols on. here, although it's not wrong if you leave them off, but just make sure you know what's what. Okay, so angle Q1 is 79.89. And I'll go record that up here. Oops. So now I have two of the three angles, right? I know angle P and angle Q. So angle R is going to be really easy. So 180 minus 56 minus my previous answer. So 4411. And now that I know one of either the angle or the side for R, I can use the law of sines to find the other piece. So again, I'll start with sine P over P equals sine of R1, angle R1, I should say, over R1. And then we just do the same thing. We cross multiply. And then divide by sine 51. Or I'm sorry, sine 56. I don't know why I said 51. Probably because I was writing the 44.11 while I was trying to say the other thing. You ever do that? Probably not, because you're not like writing notes and talking about what you're writing at the same time. But it's really, I do it all the time. It's so infuriating. Where your mouth says what your hand's doing. And I get 1343 then. Oops, I think I forgot to record that other value too. Oh, no, I didn't. So far, triangle one, pretty straightforward, right? It worked ostensibly like the example from yesterday. I mean, we had to use the sine inverse or whatever, but big whoop, that's not a big deal. Everybody feel okay to this point? Now, the obvious question is, okay, like, how do I start getting this second triangle now, right? Well, it turns out the second triangle is actually less work than the first triangle. We really only need to use the law of sines once inside the second triangle. And the reason is that there's a nice relationship between this first angle that we found. That first angle that we found in triangle 1 is the supplement to that same angle in triangle 2. If there's a place where students forget what to do or get stuck, this is almost always the place. So I'm going to just kind of highlight that, but that's always the situation. Luke? Okay. Since we know P and Q2, really easy to get R2. So that's, 2389. Let's do it here for real, just to be careful. Yep. So 2389. And then to solve for side R2, we're going to do that the same way, except instead of using our angle R1, we're going to be using angle R2. But it's otherwise the same process. So cross multiply, and then divide by sine of 56. And we get like 782 or something. I think this is my 6th time doing this problem, so that's how I know the value without actually doing the thing. Yep, 782. Everybody feel okay here? So again, really the hardest part was figuring out that 2 triangles was possible in this situation. But after that, it's just really just using the formulas over and over again, right? Like nothing too bad. Let's look at another example here. So let's say angle A is 74 degrees, side A is 2.5, and side C is 4.9. So I'll draw and label my triangle. I know I have angles A and C. I'm going to use the alphabet and choose to name the other side B. What scenario are we in? Yep, or side angle, either way of saying it. I like to not spell the swear word on my paper just in case, somebody's looking and like, what are you doing right now? It's like, oh, I'm just doing math. Why do you have swear words all over your paper? It's like, don't worry about it. So since it's a side angle situation, we know that we are using the law of sines. But the side angle situation, we have to do a little bit of analysis before we dive right in. The first thing we do is we check the size of the given angle, which is in this case acute, right, or obtuse. It's acute, right? Angle A is 74 degrees. That's acute. So I know then I have to compare that side that's opposite the given angle with the other given side. So is that side A bigger, equal to, or greater than the other given side? Smaller, right? And again, this was the nightmare scenario where it could be 0, 1, or 2. So we have to do further analysis to kind of check on which one of those scenarios we're in. So I do the bigger side times sine of the given angle divided by the smaller side. and I get 1.88. What does that mean? Since it's bigger than 1, that I have 0 triangles possible. And since there's no triangle possible, is there anything to solve for? Nah, man, I'm done. Okay, well, that's good. That kind of balances out all the extra work we have to do for a 2 triangle situation, is that on occasion we'll get these 0 triangle situations where I got nothing to do. I ain't gonna complain about that. All right, let's do another, because we still have some more scenarios we haven't dealt with yet. So here's a situation where angle A is 34 degrees, side B is 14 degrees. Oh, 14 units, it's a side, not an angle. And side C is 17 units. So we'll draw and label our picture. What situation is this? This is side angle side, which tells me I should be using the law of cosines. So using the law of cosines, the only piece of this triangle that we have enough information to solve for is the missing side length. Right now, anyways. So we'll set that up, solving for side A. So A squared is equal to B squared plus C squared minus 2BC cosine of angle A. Yeah, Sergio? I would give you the law of sines and cosines formulas. Like what to do when, I would count on you guys knowing. But I'll give you the formulas. But we don't want to solve for A squared. What do we want? Just A, right? So what do we have to do? Yeah, square root both sides. So if it's me, I'm not going to do any preliminary, like intermediate calculations or whatever. I'm just going to square root both sides and then type the whole thing into my calculator in one big piece. Because, well, less chance of me doing something stupid and doing the wrong order of operations or something, right? So I get about 9.51. For side A. Now, if I go and I still have to solve for sides B or C. At this point, though, since I know angle A and side A, I could use the law of sines in this situation. That's what I'd prefer to do because it's a little bit smaller and more compact formula than the law of cosines. Everybody okay there? Now, do you think it matters whether I'm going to be solving angle B or angle C first? What do you guys think? Do you think it matters? It only matters if you want to keep your life simple. Because if you're not careful here, what you're doing in solving for angle B or angle C is a side-side angle situation. And if you're not careful, you can stumble your way into a 0, 1, or 2 triangles scenario, which we would prefer to avoid because that's a lot of extra work. And you have one set of answers that's going to be nonsense, right? That are not going to be valid answers. So the way you can make sure that you avoid that 0, 1, and 2, or 0, 1, or 2 triangles situation is to solve for the smaller of the 2 angles. But Mr. Kulik, well, I don't know angle B or C. How do I know which one is smaller? To just look at the sides opposite the angles, right? Angles are proportional to the side length opposite it. So if side B is 14 and side C is 17, which one is the smaller? B. Yeah. So there we go. So we'll do sine of angle A over side A equals sine of angle B over side B. And then we'll just cross multiply. And then divide by sine of, by 9.51. And then we'll do sine inverse. And you'll notice I'm using the ANS command a lot when I'm doing this. That's just to avoid having to type everything in. So I'm using like my previous answer all over the place. So I get 55.44 for that angle B. And now angle C is super easy. Since I know angle A is 34, and I know angle B is 55.44, I can just add those two together and subtract them from 180. Oops, how did I do that? To get 90.56 for my third angle, and I'm done. Not too bad there, right? The only thing that we need to remember is when we're using that law of sines, that we're going to solve for the smaller angle first if we have the choice. And my last example then for today. The triangle with side P is 5, side Q is 8, and side R is 10. So we'll draw and label our picture. And what situation is this? Side, side, side. Nobody ever messes that one up. That's a law of cosine scenario, but if you remember, we put a little asterisk on the side, side, side when we told you we're going to use law of cosines to do this, because there's a little bit of a complication here. And here's the complication. If I just give you 3 lengths for the side lengths of a triangle, doesn't guarantee you can actually build a triangle out of those things, right? If I told you that my triangle had side lengths of 1, 1, and 100, if you try to picture that in your head, you're like, ain't no way I can connect those 3 things to make a triangle. So we do need to check that before we get going. Does anybody remember how we can check if 3 side lengths can make a triangle? This was from geometry. Well, it's that the sum of the 2 legs has to be greater than the hypotenuse. So in this case, let's say this first. Mr. Kulik, how do I tell what's the hypotenuse? It's the biggest one. You know, every year somebody asks me that, and every year I reply, and they always go, Oh, yeah, of course. So I'll say it now anyways. So obviously 5 plus 8 is greater than 10. So we're good on this case. A triangle is possible. Note that this is a strict greater than. If R was 13, triangle is not possible. Okay? The sum of the legs must be greater than and strictly greater than the hypotenuse. Everybody cool? Okay. Next question would be, okay, well, if I have all three sides, I can obviously solve for any of the three angles, right? Does the order matter here? Only if you want to keep your life simple. So the goal here would, again, to be avoid any future SSA situation. The way to guarantee to avoid that is to solve the biggest angle first. And again, we can find the biggest angle the same way that we did before. Obviously, that's got to be angle R, right? Opposite the biggest side. So I'd say R squared is equal to P squared plus Q squared minus 2PQ times cosine angle R. So far, so good with the setup. Number one mistake students make algebraically here is they combine the 5 squared plus 8 squared minus 2 times 5 times 8 all together into one number. What's wrong with that? Well, the 2 times 5 times 8 is a coefficient on a variable. Correct? So you can't, it's not a like term with the 5 squared and the 8 squared. You can't do that. Does everybody see that? I would, again, encourage you not to do any intermediate calculation. I'm just going to move everything to one side and then type it all into my calculator and let the calculator handle the order of operations stuff for me. So I'm going to start by subtracting 5 squared from both sides and subtracting 8 squared from both sides. And then I'm going to divide both sides by negative 2 times 5 times 8. Make sure that you're not dropping that negative sign there. That happens on a fairly regular basis. Cause you get some bonkers answers there. And then to get rid of the cosine, we do cosine inverse. And now, if you haven't been using that fraction command on your calculator like I have been, this is the time where you definitely would want to, because you need a whole heap of parentheses to make sure the calculator does the right order of operations for you with what we've written down. Or you can just do that fraction command on your calculator and then type it in exactly like it looks on your sheet of paper, and your calculator will do what you mean it to do. But if you tried to type that in one line instead of using the fraction command, I don't know, you need 2 extra sets of parentheses, which is kind of a hassle. So I get 97.90 there. Now that we have one of the angles, I know an angle and the side opposite it, so I'm going to use the law of sines to solve for the next piece. Do you think it matters which angle I solve for next? Only if I want my life to be simple. Which one do you think I want to find first if I'm using law of sines? The smaller. So in general here, folks, we use the bigger, we find the bigger angle with law of cosines and the smaller angle with law of sines if you have a choice, right? Now, if there's no choice, then it doesn't matter. You know what I mean? This is only if you have to try to choose which one to do next. All right, so I can do sine of r over r equals sine of p over p, cross multiply, and then we'll divide by 10. And then we'll do the sine inverse. Everybody's okay that I skipped the divide by 10 or combine the divide by 10 step with the sine inverse step? I think at this point we did enough of these that I can get away with getting a little loopy-doopy on my workarooskies. Since it's been the same set of steps, just kind of over and over and over again. So I do that, I get 2969. So getting angle Q is now really easy because I have two of the three angles. I can add those two together and subtract from 180 to get the third angle, and I'm all dunzos. Which is pretty cool. Pretty cool. So 5241. What do you guys think? It's not so bad, right? Yeah. All right. We're going to stop here. At this point, you guys have done enough to be able to do 1 through 22 in worksheet 1. So these guys will both go into the problem set that's due Sunday at midnight. Wednesday and Friday this week. Wednesday, we're going to do section 7.4. That's the last section in this chapter. Friday, where it's going to be the review day, where you guys can work on review and ask questions and all that jazz. On one of those 2 days, we will do the homework quiz for chapter 7. Not sure which day, but I would certainly have wanted to do, a fair bit of the homework before Wednesday, since I don't know what day that homework quiz will be happening. One of the 2 days, though. And at this point, we'd only be covering up through section 3, right? The homework quiz, since I'm announcing it kind of now. So just using law of sines and cosines. Again, I would give you the formulas on the for the quiz, but not all the details of like when to do what, or how to tell one thing apart from another and all that jazz. Sergio? Sure. And if we're reviewing then on Friday, you can count on the Chapter 7 test being the first class day next week. That's Wednesday because Monday is Martin Luther King Day that we don't have school. So there's only a 4-day week next week. All that information is on My Notre Dame and or the and the assignment center or on the home page or on our class page on the agenda. Short of the homework quiz, which obviously doesn't post anywhere until we did it in class kind of thing. You know what I mean? Any questions for me about the schedule here? Okie dokie. You guys got 40 minutes or so left of